Hey everyone, welcome back to the channel Question Code. Today we'll cover a multi-agent system using the LangGraph library. So we'll cover two workflow into multi-agent system. One will be simple workflow where one agent will do the task and it will assign the task to another agent. Then we'll cover a supervised workflow where supervisor will be decide which agent we need to call. So first understand what is LangGraph. So it is a library built on the top of LangChain. It is basically designed specifically for building these stateful multi-actor applications. It allows the define graphs where each node in the graph represents the agent, and then we have edges which will define a path between one agent to another agent. The beauty of LangGraph is basically how it manages the state, the current information and progress. So in this video, we'll explore these two multi-agent applications. I'll walk through the code of these two workflows. You can import the code from GitHub. I'll post it to description and you can explore it on yourself. Let's understand from start. Let's the output. Here we are importing all the necessary import statement here. So here first is human message, AI message. It is to basically converses to maintain the conversation between AI and human. And then we have chat OpenAI. We are using the OpenAI model. That's why this is required. Then we have tool. Tool is basically to define any function as a tool. Like for web search and summarization, we are defining a tool. And then we have tably search. It is for searching on the web for any latest information. Then we have state graph, which is current state. It contains the current state of that message into that node. Then we have end, which is the last node. We have memory saver to save the memory and increase the reliability between these agent conversation. Now we are importing our .env. We are defining OpenAI API key and we are importing it here. Let's execute this. Now we are defining the state of this message, agent state. It will contain the current message and next which agent we need to call, it will contain that also. Let's execute this. We are using a GPT-4 model. You can use any other model if it is required. So we are getting the client here. Now we are defining the agents. So we have defined like first is the research agent, which will research on any data that any prompt that we provide. We are giving prompt here, you are research agent, use the web search tool to find the latest information about the user's request. And we are giving this response to and working into the LLM. We are storing it into the response and it is executed. Then we have different agent here, writer agent. Basically it will does the technical writing based on these data that we are getting from the research agent. Let's define this also. Then we have tool executor, which will decide basically which tool we need to call. For web search we are using one tool, for summarization we are using different. And then we are building graph here. I've already defined this into a LangGraph video where I've defined like what is edges, what is nodes. We are defining here three nodes. One is the researcher, tool executor, and writer, which will do this task, particular task. Then we are defining the edges. One edge is going from researcher to tool executor, second from tool executor to writer, and then writer to end. Let's execute this. Here is the workflow. This is a very simple workflow. Let's give the prompt to the workflow and get the response. Research about the use case of agentic in business. Let's execute this. It will take some time so that all the agents can execute the task and we can get the response. In 8 seconds it is completed. Let's print the output. Here we are getting the complete research report based on this prompt. So this is very simple workflow. Now we'll explore more into the complex workflow, that is basically supervised workflow. Now let's move into a more sophisticated setup, that is a supervised multi-agent architecture. Here a central supervisor, it will act as a conductor and it will orchestrate which agent we need to call where. This allows us more dynamic and intelligent workflow. Now let's walk through the code. This I've already explained about this input statement. We are defining our supervised state here. Here next agent, it is to store the output from the researcher agent. Like it will determine which agent we need to call the next. Then we have research data. It will store the output from the researcher. We have analysis to store the output from the analyst. Then we have final report, which it is to basically store the final report from the writer. Similarly, we have task complete. It is a boolean flag to basically indicate whether that agent task is completed or not. It is current task. This flag is variable is used to keep the track of the specific task that supervisor is managing. So for our supervised state, we have maintained the supervisory state class. It also inherits from the managed state. And let's execute this. Here we are creating this method create supervisor chain, and we are defining all the agents that we require into this. One is the researcher, one is the analyst, one is the writer, and we are giving the description about this, and basically we are storing the current state and the next state also. Let's execute this. Actually, we use here chat from template to define the system rule and instructions. The supervisor is told to manage a team here about this researcher, analyst, and writer. Is it executed? Yeah. Here we are defining our supervisor agent. We are storing the current state of the message, and here the task. So task, it extract the current task from the latest message. This has research, it checks the state to see like which agent of the task have been completed, like research data, analysis, report, anything. Then we have has analysis and has report also for similar things. Then we have here this chain, what supervisor chain we are creating. And now we have here decision text. It is basically the LLM response is cleaned and covered. Now we are invoking our chain here with task and these three flags: has research, has analysis, has report. And then we are basically cleaning the LLM response and making it into lowercase. We are printing the decision text here, and we are here determining the next agent what we need to call into the if else blocks. If done into decision text, then we are calling the supervisor message. And if uh, like a researcher need to call, then supervisor will call research. If analyst need to call, it will call to analyst. If writer need to call, then it will call to the analyst agent. And then we are returning this message and the next agent and the current task. Let's execute this. Similarly, like the supervisor agent was created. Now we create these three agents also. Researcher agent, we are giving complete prompt what it needs to do about the complete current task, what it should include, and we are invoking the LLM here. And let's execute this also. Similarly, we have analyst agent. We are giving the prompt. We are giving all the tasks here. Let's execute this. And we have writer agent. So all three agents and supervisor agent is created. Now we'll create the router here. Router will basically pass the task from supervisor agent to different agent. This is executed. Now we'll create the graph here. This is a state graph which will contain the current state of the message. These four are the nodes, and like we are here defining the routing, like from supervisor to researcher or analyst to our writer, which agent we need to call. Let's execute this. Let's print the graph here. So this is a supervised multi-agentic system graph where one supervisor is there. It will decide whether we need to call to analyst, researcher, or writer. And this data is also, it will flow backward also, like from analyst it will give to supervisor, so that supervisor can will have this current data and it will call the researcher with this data. Now we are invoking here the what are the benefits and risk of AI in healthcare. We are invoking this method, this star. It will take some time to complete this. It will take some time basically because multiple agents we need to call. It is executed in 36 seconds, and these three agents. Now let's print this response, and we are getting the final report here. Analyst writing and the report, complete report created by this multi-agent. And there you have it. So we have walked through the creation of two distinct multi-agent AI system using the LangGraph, from a simple linear pipeline to sophisticated supervisor-driven orchestrator of agents. So LangGraph basically it provides the tool to build incredibly powerful and dynamic AI application. I hope you have understood a little bit about these multi-agent system. You can import this code and walk through your own. You can write this code on your own for better understanding. We'll meet into the next video where I will explain you about the debugging of this LangGraph and multi-agentic system using the LangChain. Uh, Thanks for now joining. Thanks. Bye.